Right, this is a lesson on analytically or using algebra is kind of what that means, determining if a function is odd, even, or neither. Now, odd, even, and neither talk about the symmetry of a function. If we were to graph it, is it symmetric? Even functions are symmetric with respect to the y-axis. And odd functions are symmetric to the origin. Now, if you're trying to determine using algebra whether a function is even or odd, what we do is we test them by plugging in a negative x for all of our x values. If the function is even, then when we plug in that negative x value, we will come out with exactly the same function we started with. There will be no changes. If the function is odd, when we plug in that negative x, we'll come out with the same function, except it will be as if we had multiplied everything by a negative. Okay? If you don't come out with either of those two results, then it's neither. So let's try this example. If f of x is equal to negative 3x, so again, our test is to replace all of the x's with a negative x. So instead of negative 3x, we'll have negative 3 times negative x. Now we want to go ahead and simplify that and see what we end up with. Well, negative 3 times negative x would be a positive 3x. Okay? So we found that f of negative x, when we put a negative in for our x, we got 3x back. So then our question is, does it look exactly the same as our original function that we had? Now I'll remind you, if you look back up there, the original was f of x equals negative 3x. Does it look exactly the same? No, it doesn't. It has a different sign. So this is not an even function, okay? Not even, because we should have come back to exactly the same thing if it were. Is it an odd function? Is it the same function, the only difference being we multiplied everything by a negative? And yes, that is the case. Notice if we took our original function and multiplied it by a negative, we would get positive 3x, which is what our result was. So this is an odd function, because when we plugged in a negative x, we got the same function. The only difference was it was as if we had multiplied the entire function by a negative. Now in your head you may be saying, well, isn't that going to happen every time? And the answer is no. Most of the time you'll actually get neither. Not in these examples I'm giving, because I tried to show lots of examples where it's either odd or even. But let's try this one. Okay, so again, remember that an even function, when we do f of negative x, we get our original function back. And an odd function, when we do f of negative x, we get the original function multiplied by a negative. Okay, so let's try this out. We take our function and we do a negative x in place of all the x's. So we have 5 times negative x to the third plus 2 times negative x minus 1. Then we simplify that. Now with powers, when you raise something to an odd power, you come out with the same sign. So negative x times negative x times negative x would just be a negative x. So this gives us, whoops, my arrow's there. Sorry about that. This gives us negative 5x to the third. 2 times negative x is going to give us a negative 2x. And on the end, really nothing happens to our negative 1. So then we go back and we say, was this the same as our original function, which would be 5x to the third plus 2x minus 1? Or is it the same as our function if we multiplied everything by a negative? So let's look at what would that look like. That would look like negative 5x to the third minus 2x plus 1. Okay? Did it come out as either of those? Does it look the same as our original function? Well, no. It has the wrong signs here and here. Does it look like our function if we multiplied our function by negative 1? Well, the first two signs are okay, but down here on the end where we didn't have an x, it's not okay. It didn't come out right. So this is going to be neither is my answer here. It wasn't odd and it wasn't even. It is neither. Okay? Let's try another one. Okay, this time our function is f of x equals 4x to the fourth minus 2x squared plus 5. So again, we're going to take that function. Okay, it will be even if it comes out exactly the same. So if when we plug that in, if it comes out as 4x to the fourth minus 2x squared plus 5, then it's even. Okay? It's odd if it comes out when we put in a negative x. If it comes out as if we took the whole thing times negative 1. So let's look at what that would look like. It would give us a negative 4x to the fourth plus a 2x squared minus a 5. Okay? So it's going to be even if it comes as the first thing, odd if it comes as the second. Let's see what happens. We take f of negative x. That would give us a 4 times negative x to the fourth power minus 2 times negative x squared plus 5. Now let's simplify that. And negative x to the fourth power, anything to an even power is going to come out positive. So that would give us positive 4x to the fourth. Okay? Here again, negative x squared would just give us x squared, so that's not going to change our sign at all. And then we have plus 5. So what did we come out with? Did we come out with an even or an odd? Well, notice that this is exactly the same as the function we started with. So this would be even. Okay? Carry on. Give us another example. F of x equals 5. Okay, so is it odd, even, or neither? So let's look again. I'm going to write down again. Even is if when you put in the negative x, you come out with the original, which in this case would be, okay, 5. Okay, and it's going to be odd if when we put that in, we get our function multiplied by a negative 1. So if it comes out as negative 5, it's odd. Well, let's try this. What if we do f of negative x? We're supposed to replace all of our x's with a negative x, but notice there's no x's. So really, it can't be changed, and this ends up being an even function. Okay, because the function was unchanged, mainly because there was nowhere to put an x, therefore it really couldn't change it. Okay, let's do one more. Odd, even, or neither. So again, I'm going to put in our little, what would even look like. Okay, and that's when we put in our negative, we get our function back exactly the same as it originally was. Odd, again, when we put in the negative x instead of the x, we were supposed to get the function as if it had been multiplied by a negative. Which, what would that look like? You go up to your function. If I took everything times a negative, it would just change all of my signs. I would have a negative x to the third plus x. And let's go ahead and do our trial. So we put a negative x in for all of our x's. And into the original function, that would give us a negative x quantity to the third minus a negative x. Now, when you take something to an odd power, it doesn't change its sign. So this is simplified. It's going to come out as negative x to the third. And then here, negative times the negative makes that a plus x. So do we have odd, even, or neither? Well, it's not the same as our original function. It has the wrong sign, so it's not even. Is it odd? It is odd. It's exactly the same as our function. It just has been multiplied by negative 1. So this one is odd. Okay, hopefully that is helpful. If you have more questions, you are welcome to contact